Now that we've talked about logarithms being inverse operations of exponents and we've looked at the graphs, we're going to talk about the properties of logarithmic functions. And this allows us to simplify logarithms and maybe expand it to make things easier to evaluate and things like that. We use this a lot in advanced mathematics, so in classes beyond this. So it's an important skill to have, especially if you're going to move on. All right, so first we're going to have the product property of logarithms. This one says that if I have log of any base, and inside that single log I have m times n, then I can separate that into two separate logs, log base b of m plus log base b of n. So notice that I have a single log, and that's the same as two separate logs added together. Okay, so here's an example of that. You see I have log base 5 of 2x, and they split it apart into two separate logs. Both logs have the same base, and they each have the individual things that were multiplied together. So if I do that same property for this log base 2 of 4x, that would be log base 2 of 4 plus log base 2 of x. So this is a perfect example of why we would want to do that. I can easily solve 2 to what power gives me 4? That'll be 2. So instead of writing log base 2 of 4, I could write this as, I'm running out of room. I'm going to write this in green up here. I could write this as 2 plus log base 2 of x. So I've simplified that a little bit more by expanding that. By the way, this is called expanding logarithm. So if you ever see directions that say expand it, you're using these properties to make it longer. All right, what happens though if we have, like in this problem, we have 3 things multiplied together? That's okay, we just add 3 things together. So I'm going to have log base 6 of 5 plus log base 6 of x plus log base 6 of y. So I just have, if you have 3 things multiplied inside one single parenthesis, then you have 3 things added together as 3 separate logs. Now we can also use this property backwards to condense logarithms. So if you notice that you have the same base of 2 things added together, then we can combine them into one single log. Now this only works if you have the same base. So these are both log base 2. So I'm going to combine these to be one single log. And instead of, we were doing log base 10 and then log of 5. Instead of adding those things together, when we're in a single log, they get multiplied together. And now I can simplify that even further, because I can do 10 times 5. 10 times 5 is 50. So this is the same thing as log base 2 of 50. All right, if I do the same thing here, over here I have the log base 5 in both of these. So I can combine these to be one single log, log base 5 of 3 times x. Now, I can't multiply 3 times x, so I'm just going to leave that as 3x. So that's the product property of logarithms. We also have the quotient property. This one says that if I have log base b of m divided by n, so notice I have a single log and my 2 things are divided, that's where the quotient, remember quotient means the answer when we divide. So if I have 2 things divided, then I can split them apart into 2 separate logs, but now those logs are going to be subtracted. I forgot my m. So this will be log base b of m minus log base b of n. Notice that the numerator comes first, that's the positive one, and the denominator comes second, that comes after the minus sign. So if I do that on this example, I have log base 3 of 4/5. That would be the same thing as saying log base 3 of 4 minus log base 3 of 5. Same thing over here. If I have log base 5 of x over 3, that's going to be the same as log base 5 of x minus log base 5 of 3. So that's expanding again using the quotient property. I could also condense using the quotient property. So if I notice again that I have the same base and these things are subtracted, then I can write that as one single base, log base 3, and then inside that single base, 8 and the 4 will be divided. And 8 divided by 4 is just 2, so I can simplify that even further. So I'm going to write that this is log base 3 of 2. Over here, I have the same base, log base 2. So I'm going to write this as a single log base 2. And inside I'm going to be doing x divided by 5 since they were subtracted. All right, so moving on to the next property, we have the power property. The power property says if I have log base b of m raised to the n power, then I can write that as n times the log base b of m with no power on it. Okay, so I basically brought the power in front of the log. So here's how that works. If I have log base 5 of x squared, 2 is my power. I'm going to rewrite it so that the power is in front of that. So that looks like 2 times log base 5 of x. Okay. Now over here, in this second example, part B, notice that I don't just have a power, but I have two things multiplied. So I'm going to use two properties here. I'm going to use the product property and the power property. So the first thing I'm going to do is split that up, because the cubed is not on both of those things. The third power is not on the x, but not on the 2. So I want to split those up first before I do anything with the power. So first thing I'm writing this as two different log base 5s. One has log base 5 of 2, the other one has log base 5 of x cubed. So now I'm going to worry about the power rule. Now I can take this power and put it in front of that log. So this is going to be just brought down, log base 5 of 2. This one's going to end up being 3 times the log base 5 of x. So that's how we've expanded that. And then our change of base formula. This is important because this helps us do whatever we want on the calculators. So you might even want to put a star by this one and say, this is how you do in the calculator. Okay, so change of base says this. If I have log base b of m, that can be log base, whatever base you want it to be, a new base, log base n of m over log base n of b. So here's the difference. N is a new base. You get to pick whatever base that is. M is in the numerator and b is in the denominator, right? So m goes here, the base is in the bottom. Now, if I get to pick whatever that is, I'm going to pick something I can put in my calculator. So here's what we really use this for. I can use this as log base 10, right? Remember, if I don't have the base written, that's assumed to be log base 10, so I can use the log button on my calculator. Or I can use the natural log, the ln button on my calculator. So here's how that is useful. If I'm going to evaluate these expressions, well, first of all, I don't just have one thing going on here, I have something plus another log. But do you notice how this is log base 5, and this one is a log without a base written? Remember, that would be understood to be log base 10. All right, so I cannot combine those. So don't try to do that product property. We can't do that here. But for the log base 5 of 3, I can use change of base and say, okay, I'm going to do log, I'll actually write the 10 this time, log base 10 of 3 over log base 10 of 5. That's that change of base formula. And then over here, I can do log base 10 of 2. So how is this helpful? Well, now I can go to my calculator, type this in. So we would literally type in our calculator log of 3, close your parentheses, divided by log of 5. Make sure to close your parentheses for those steps. We don't want to enter it in incorrectly. So I get something like this, 0.683 about. And then when I do log of 2, then that gives me 0.301. So now I can add those together and get the total is 0.984. So that whole expression is equal to that decimal. And I've taken something that I couldn't type in log base 5 into my calculator, but now I can. This one is a little more straightforward. So it's log base 8 of 1/4. So since we did log base 10 in the first example, let's do natural log. So I'm going to do natural log of, remember this goes in the numerator, so 1/4 divided by natural log of 8. Base always goes in the bottom. Okay, so I'm literally typing in ln on my calculator, 1/4, close your parentheses. Then I'm going to divide by ln of 8. This gives me negative 0.6 repeating. Or if you know what that is as a fraction, that's negative 2/3. That's okay. You don't have to know that if you don't know that. But either way, we're getting our answers because of that change of base.